Hey everyone! Thank you for joining us for the next session of our Python and MCP from Local to Production series. My name is Anna. I'll be your producer for this session. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our moderator to answer. Our session is being recorded. It'll be available to view on demand right here on the Reactor channel. With that, I'll turn it over to our presenter for today. Pamela, thanks so much for joining us.
Hello, everyone. Welcome to our Python MCP series. Don't need headphones. So we are doing this three-part series. This is part 3 of the series. We already covered how to build MCP servers in Python using FastMCP and running them locally. And then on our second session, we deployed them to Azure Container Apps and even put them inside a private network to show how we can do that. If you missed those 2 sessions, they're all recorded on YouTube, and all the code and slides is available so you can catch up with anything you missed. Today is our 3rd part of the series, and it is the final part. And we thank all of you for joining so far in the series. Today, we're going to be talking about how we can take our MCP servers and add authentication to them. And we're going to look at a few different ways of doing authentication that we think will be the most helpful for all of you. Now, if you want to, you can download these slides and follow along with them. We'll share the link in the chat. And yeah, you can follow along. You can share the slides. You can re-give these slides to your friends, family, colleagues, whoever, whatever you want to do with them. If you haven't met me before, my name is Pamela Fox. I'm a Python cloud advocate at Microsoft, which means my job is figuring out how to make things work with Python. And these days, that's all about making generative AI technologies work with Python. And it's a pretty fun job. All right, so let's dig in for today's topic. And I know a lot of us are very excited about this topic because it can really make our MCP servers more powerful when we're able to have authentication layers. So we're going to be talking about different ways of restricting access to MCP servers. We'll look at key-based access, and then we'll really spend a lot of our time on OAuth-based access because that's where things get very interesting. We're going to demo a Keycloak integration and then also an Entra integration. So first, just generally, how do we restrict access to our MCP servers? Now, remember, overall, this is our MCP architecture, right? We've got these MCP servers that we're building, and we're hosting them on some machine somewhere in the cloud. And these MCP servers expose tools, and they might also have prompts and resources, right? But mostly they're exposing a lot of tools. And then we've got MCP clients that interact with these servers. Now, these clients might be, like desktop applications like GitHub Copilot or Claude Desktop. The clients could also be agents that we're writing ourselves, right? Maybe an agent written with LangChain or Agent Framework, right? So these are, the clients using the MCP protocol in order to get responses back from those servers. Now, we may want to restrict which clients can access which servers. So what mechanisms do we have to restrict that? So I would say there's 3 primary approaches. The first one is that we can simply make sure that our MCP server is not publicly accessible, right? That if you try to reach that URL, you will just, get kicked out, get a 404, a 401, whatever. You just can't reach that URL. And we talked about that in yesterday's session, is how we can deploy our MCP servers inside private networks and disable public ingress to that network. So that is definitely an option, especially if you're developing MCP servers solely for internal use. However, you might be developing servers that you do want the URLs to be publicly available, but you want to make sure that whoever is using them is allowed to use that server, right? So the first thing you might consider is using key-based access. So here you give out keys to your server and you say, hey, as long as you have a key, you can get into the server, right? So then that means you need some way of creating keys, granting keys, some way of verifying that, you know, that key is correct and looking up in your system and say like, oh, this user has this key. Okay, you can use the server. So that's a very popular way of gating access to MCP servers. And then what gets really interesting is when you do OAuth-based access. So here you say, okay, I want only certain sets of users to be able to access this server. And when they access my server, I actually want to know who they are. And I'm going to restrict what they can access based off who they are. And so here we can actually use the OAuth spec, the OAuth 2.1 flow, in order to have an MCP client authenticate a user and then give that MCP server access to, you know, the OAuth tokens, and then use that to decide what data it's going to send back, and, you know, do flows on behalf of that user. And so that's a really interesting approach that we can use. So first, let's talk about key-based access, because that is a simpler way of restricting access and can potentially be what you need. So what does this actually look like with the MCP protocol, right? So remember, we've got our MCP client, we've got our MCP server. So the MCP client is going to communicate to the MCP server. Here it's sending a post to the /MCP endpoint. And in that post, it's including some headers. And oftentimes we put the key in the header, right? So in this case, I have a header here that says, oh, the API key is, you know, ABC123, that gets sent to the MCP server. And the server says, oh, okay, I know that key, that is a valid key. Therefore, I will respond and, you know, call that tool for you, right? So that's basically how it's going to work. Now, there's many ways you can specify keys. Some people put keys in query parameters. Some people put them in headers. Sometimes they put them in the header bearer token. Lots of places you can put the key, but, you know, some way of sending a key over HTTP. So how can we use, so first I'm going to show how we can use a public MCP server that has key-based access. So I found this fun server yesterday. This is the Tavily server. Tavily is a service for searching the web. So many people like to use this server so that their agents, like their coding agents, have more up-to-date information from the web instead of relying what's in the weights of the model, right? So here you can see their MCP servers available at a URL, mcp.tavily.com/MCP. And for their keys, they have you put it in the authorization header, right? So we say authorization bearer, and then we put the key in there. Now, when we're configuring an MCP server in VS Code that expects a key, something that's nice that you can do is you can actually tell VS Code like, hey, this is a key, this is secret, I want to keep it secret, and VS Code will store it in a secret store for you. So that way you don't have to worry about exposing your secret. So it'll prompt you for it, save it, and then it'll be there. So let me show you, let's see, I've got it running over here. Okay, so here you can see I've added it to my global MCP .json configuration. So that way I can access this Tavily MCP server from all of my workspaces. And yeah, so let's just start this. Oh, you can see here. So when I press start, it pops up this thing that asks for my API key. So I'm going to go over here and grab my API key. Okay, great. All right. So now I'm going to enter that, and it saves it, and it started, and it's got tools. So now we have a connection to the server. So now I'm going to check my Copilot chat and see, I'm going to enable it. And underneath it, we can see it's got the ability to crawl, extract, map, and search. That search one is the one I really want to use. So let's try searching. So we're going to say, what is the latest LLM released by Google? All right. Now the question, you know, here I'm asking GitHub Copilot this question, and GitHub Copilot now knows that it has the Tavily MCP server it may not decide to use it, right? An agent, you give an agent a bunch of tools and the agent has to decide what it's going to use. I'm hoping it, oh, good. Okay, great. So it did decide to use that server. So here we can see it says, okay, I'm going to search. I'm going to look for this, right? It's added on DeepMind announcement. Okay. So let's see. I'm going to say allow. And now it is running against that server. And so that is, VS Code is passing my key to Tavily and getting back responses successfully, right? So we can see a bunch of things and say, as of December 18th, the latest LM release is Gemini 3 Flash. Now, the funny thing is I used Gemini 3 Flash as my model for asking this too, but it clearly got this information from the actual web search, right? And so that's, it's very powerful to use an MCP server like Tavily, which gives your agent the ability to look up updated information like that and get back the results. But the main goal here is to show you just how you can use a HTTP MCP server that expects a key. So here, this is how I use it in VS Code. I can also use it from a programmatic agent, right? So I'm going to go back over to another repo. So this is this code that I'm about to show. This is in the Python MCP demos repo. This is the repo we've been showing throughout. I just added this demo last night. So if you did already check out the repo, you're going to want to git pull the latest changes. So underneath agents, I've got an agent framework Tavily example here. So what you can see is that we can say we want to use this MCP server as a tool. And here's the URL. And then the headers are passing in that key, right? And then we tell it to search the web. And here I'm asking what's new in Python 3.14. Okay, so let me go ahead and run this. And I've already saved my key into the environment in this terminal. So hopefully it should have access to this environment variable that has the key in it. And it should be able to pass it in. So we're passing it in here. And remember, this key is per user. So Tavily has set up a system where they've given me a key and it's just for me. And if I accidentally expose it, like sometimes when I'm live streaming, I might accidentally reveal a key. If I accidentally reveal it, then what I would do is delete that key and create a new one, right? The general risk of keys is that you might expose them, right? Like you might check them into version control. You might flash them on the screen when you're presenting. You might just accidentally put it in your JavaScript code and reveal it that way, right? So there's a definite risk of keys, and that's why we often don't use keys at Azure when we can avoid it, because we have other ways of doing access. But many MCP servers will give you keys. Many APIs will give you keys, and so you just want to store them as securely as possible. And if you know that a key has been compromised, then you want to revoke your key and make a new one, right? All right, so now, okay, so let's see. So it did query, it ran the framework and it got a bunch of information about Python 3.14 and it got a bunch of citations, right? So it successfully used the Tavily server. We could also do the same thing with LangChain. So we've got a LangChain example here because I know we've got some LangChain fans in the chat. So, this looks really similar, right? We grab our key from the environment. We set up our MCP server, pass the key in, the headers, the way that this server expects. Remember, every server expects different things, right? Like actually, even this server also accepts doing this. But I think that's not as nice looking. So I went for, doing the bearer token, but, generally every server will set it up a different way as to how you pass in the key. And you just have to make sure you pass it in the way that server expects. Okay. And we got a very similar response from LangChain. So that is how we could use a public MCP server with a key. The next question is, how would we build our own server that has key-based assets, right? So if you wanted to deploy an MCP server with key-based access on Azure, what strategies might you use? One thing that you could do is Azure Functions, because Azure Functions does actually have built-in basic support for keys. It's really designed more for like internal tools and prototyping. It's not designed for like APIs that you're going to give out to thousands of users, because it's only a couple keys, and it doesn't have like built-in key rotation and all this stuff. But you know, it can be an option for you, and you know, it's very easy to set up. So I'm going to show a demo of that one. And then there's Azure API management. So this is what you want to use if you're truly setting up like a public facing API and you want something, you know, similar to what Tavily has here, where, you know, a developer can actually have a portal, and in the portal, they can see their keys. So API management can set up a full public facing API for you, which has a developer portal, which will give out keys, and you know, can let developers revoke their keys and do new ones. So it's basically like, you want an API, boom, Azure will help you make an API. So I really love that. I think it's very cool how easily anyone could set up a public API now, thanks to services like Azure API management. So that is what you would want to use if you were actually going to develop an MCP server like the Tavily server, where anyone could go to your web page, sign up, get an API key. So how can we deploy an Azure function with key access? We have this repo here that you can use to do this. This repo actually supports both key-based access and OAuth-based access. So if you want to use the key-based access, I gave the instructions here. You just set a variable when you're doing the deployment, and then that'll set up the app. So I can show you, I've got the app, the function app running here. So you can see our lovely not found at the root, and then we go to /MCP, and we see the error that we always expect if we go to /MCP, because you can't do a get to the /MCP. So here we can see that we indeed have an MCP server running. And if we look at the functions, we can see that there are keys for the function, and these keys, we've said that in order to use this function, you have to pass in one of these keys here. And then we can add new keys if we want to, right? So I've got that function set up, and let me show you what that function actually does. So here is the function. It is using FastMCP, as we've seen before. So we're using FastMCP, but we're also using Azure Functions. And this one it's a weather MCP server that's using an API to get back the weather and return it. So that's what the function code looks like. And then in order to use this function, here I've got it set up in VS Code. So this is the URL of the function that I was just showing in the browser. And in this case, in order to pass in the key, we're passing in the X functions key header. This is what Azure Functions expects. And we're telling it to use this function app key here. And I've already set it in VS Code. So that's why it shows it as like this password, indicating that it's already stored it, right? So this is how we securely store keys in VS Code that we're using with MCP servers. Okay, so now that that's set up there, I can go and check to see which ones I'm using. So we can see deployed MCP server is enabled. That's the one that's pointing at the Azure function. So then I'll say, are there any weather alerts? We'll check for our producer in Washington. I think they were having flooding this week. So let's see if it'll call there. So here you see it wants to call the deployed MCP server, this one here, the Azure function, and it is passing it the state WA, because that's what that function expects, and running it. And it's also going to get a weather forecast for that latitude longitude, because it knows the latitude longitude of Redmond, Washington. So it's running a few different tools here. And in order to call those functions, it was passing the key, right? Because this function is gated based off of key access. So here we go. There are indeed some floodings. Secure your garbage cans and patio furniture and avoid flooded roads. All right. Great. So that is that's how we can both build a Azure function that has key-based access and then use it inside VS Code. Okay. So that is what I want to show in key-based access. I also encourage you definitely to check out API management as an approach there if you are setting up a public MCP server with API keys. Now we're going to dive into OAuth-based access to specifically so we can allow users to authenticate to our MCP servers and that we can do things on behalf of those users. So what this is going to look like once we get it set up eventually is that the MCP client is going to send a bearer authorization token. And this access token here is going to be an OAuth access token. And the MCP server will receive that access token and validate it as a valid token and then know who, that person is authorized to access that server and then potentially do things on behalf of that user. So that is our end goal to get to that point. Now, to get to that point, it's actually a fair amount of work involved to be able to have a client send the access token to the server. So in order to understand how it works, we're going to talk a lot about OAuth 2.1 and a lot of additions to OAuth 2.1. There are a lot of diagrams in the next few slides, and because when it comes to OAuth, it's a bit complicated. And for me, at least the way I understand it is by thinking through the diagrams and tracing the path of OAuth in these diagrams. So just mentally prepare yourself. We are going to talk about OAuth. And I will say, I don't consider myself an OAuth expert, but it is a really powerful technology. And so I always appreciate the opportunity to learn more about OAuth and try to understand it more deeply. So we are using OAuth 2.1, and in OAuth 2.1, there's different entities involved, right? So we have the authorization server. So for example, Microsoft Entra is an authorization server. So it has this notion of users and who's allowed to access it, right? So that's our authorization server. And then we have the resource server over here. This is the one that has the actual, resources that the user wants to access. And they want to be able to prove that they are authorized to access those resources. So in our case, the MCP server is the OAuth resource server. And then we have the OAuth client. And in our case, it's the MCP client. And the client wants to be able to access that server on behalf of the user who is the resource owner, right? So you can think of this as like when we're using like VS Code with GitHub Copilot, like, I'm the user. I want to use GitHub Copilot in order to access, my resources, like my, Word documents, based off of my Microsoft Entra identity, right? So there's all these entities involved in this OAuth 2.1 flow. So here is the simplified flow of OAuth for MCP. We'll start with the simplified flow, and then we're going to add a few things to it. And maybe I should have actually animated this, but we start off with the user, right? So the user wants to do something that requires an MCP server, right? So the client is like, okay, I know this user wants to use this MCP server. So what I'm going to do is ask the author, first it checks to see if it's already authenticated. But if it gets like a 401, it's like, okay, I got to redirect to this authorization server and ask for authorization, right? So we go to the authorization server, and that authorization server presents a prompt to the user that says, hey, user, who are you, right? Enter your login information. So the user says, okay, I'm Pamela Fox. Here's my password. And then the authorization server says, oh, okay, I see who you are. Now I'm going to make sure that this MCP client is legit, right? So at that point, it both authenticates the user and checks to make sure that it knows who this client is and that the client is allowed to, be asking for things from the authorization server. So then it'll say, okay, I verified the client. The client, wants access to your account. The client wants to do, it wants this scope from your account. Do you agree, right? So to say, okay, do you agree to give this client access? And the user says, oh, okay, yeah, I'm okay with that client having access. Great. That goes back to the authorization server. And then the authorization server says, okay, great. Here is your authorization code. And the MCP client then exchanges that authorization code for an access token. And the authorization server says, okay, sure, here's your access token. And now the MCP client has the access token and it can send a request using that access token. And that'll go through to the MCP server. The MCP server will do validation of that access token that it looks good. And then if it's good, it can return authenticated results. And it can look at the claims in the token to get more information about who's trying to access it. So all of that was to get to this stage here, right? To be able to have it send an access token. We had to go through all of those steps. And remember, this is the simplified flow. So we're going to dig into a few more steps that don't quite fit in this diagram. So the first step is that the MCP client needs to figure out what authorization server it is going to redirect to. So this first change we're going to talk about really happens before this arrow here. The client is not sure who the authorization server is. It needs to have a way to discover the correct authorization server. So this actually requires effort from two different entities. First, the MCP server. The MCP server has to support what's called protected resource metadata. This is a document that says, hey, this is the authorization server that I expect you to be using, right? It'll include this authorization server, also includes scopes. So that PRM is located at some URL on the actual MCP server. So that is something that if you are building an MCP server, your MCP server needs to have a route that will give back that PRM information. So then that'll go back to the client. The client's like, oh, okay, I see which authorization server you're saying I should use. Then the authorization server itself has to provide discovery of some additional information because there's multiple URLs involved with authorization servers. So the PRM is only going to list the main authorization server URL. Then the authorization server has to give back an additional document that says, okay, yeah, for my server, here's all the detailed information about how you're going to authenticate. So what does this look like for PRM, right? So it starts off, the MCP client attempts to make a request to the MCP server and it doesn't have a token yet, right? So the MCP server, when it gets a request that does not have an access token, it returns an HTTP 401 that says, hey, you're not authorized. And it adds an additional header. This is a special header called www.authenticate. And that header contains the URL for the PRM, right? So then the client says, oh, oops, I need to get a token. How am I going to do that? Let me find out some more information. It goes and it fetches that URL. And then the server says, sure, here's the PRM document, right? And it's just a JSON document. So that's one flow that you can do. The other flow is that if the MCP server returns back 401 unauthorized and doesn't have that www.authenticate header, then the MCP client just tries various PRM URLs. And this is what's called a well-known URL. So it's like .well-known/protected resource metadata. So it'll just try these conventions, these URL conventions, and it'll hope that it finds a PRM at one of those URLs. And once one of those is successful, then it's like, great, I found the PRM. Now I've got the information about what authorization server we need to use. So We've been using FastMCP to build our Python servers so far. As long as you're using FastMCP and you're using one of the auth providers inside FastMCP, it will actually automatically add the PRM route for you, and it'll add that header. So if you're using FastMCP with any of the approaches we're using today with the auth provider, PRM will be taken care of for you. So it'll just add in this route, which is .wellknown / OAuth protected resource. That is the route that every MCP client knows that it needs to look for in order to find the PRM. All right, now we are moving on to the authorization server. Once we find out which authorization server we're using, we need to get additional metadata from that authorization server that says exactly how to use that authorization server. So the MCP client, once it gets back that PRM, it gets back the authorization server URL, it's going to make a request to the authorization server's well-known URL and then hope that it gets back a response. And there's 2 or 3 different URLs it'll try. So once again, these are well-known URLs where they are a particular path that starts with .wellknown. It'll just try these in order based off whether the authorization server was just a root path or had a path in it. And it'll just try those. But basically, there's a bunch of well-known URLs. The client will just try these in order until it finds that JSON document that contains the additional information. One thing I've discovered about OAuth, it has a lot of reliance on well-known URLs. So we've got the well-known URL for the PRM, and now we have this well-known URL for the authorization server discovery as well. So basically, an authorization server needs to support one of these URLs, right? So for example, Entra supports the this final one, the OpenID configuration URL. So it actually does support this metadata discovery flow. Okay, so now we covered, so all of that actually happened before this flow even starts, right? Because the MCP client had to figure out how to make that authorization request. So it had to do the PRM and then the authorization server discovery, and that got it to the point where it could actually make this authorization request, right? So good. So we got to that point. Now, there's another part of this flow that is interesting, and that's this part right here, right, where we validate the client registration. And that is tricky because usually authorization servers know which clients want to use them and are pre-registered. But with MCP, we have people using all sorts of MCP clients, right? They can be using VS Code, Claude Desktop, ChatGPT, any of the other hundreds of MCP clients that are out there, right? And ideally, your MCP server would be usable with arbitrary MCP clients, right? So how can the authorization server validate client registration if it's never seen the client before, if it's an arbitrary client? So that's where we get into the next interesting part of the OAuth for MCP. So here's the flow I came up with here to talk through this. So if the authorization server does know the MCP client, that's what's known as pre-registration. And in that case, it's quite easy because, the authorization, already knows. It says, great, I know you, you're good. Check, you're good to go, right? And so sometimes we do pre-registration, like especially if you're building both the client and the server, or if you're only trying to support a client like VS Code, Copilot, then that's fine. You can use pre-registration. But most people want their MCP servers to be usable by a bunch of MCP clients that you may not know. So in that case, we go down this path here, right? And there's 2 different options that we can use as part of MCP Auth. So first, we check to see, okay, does the authorization server and the MCP client support what's called CIMD or SIMD? So if they support SIMD, which is a new OAuth specification, like very new, like the last 2 months new. So it's a very new OAuth specification. So it is not well supported yet. But if you are lucky and both the authorization server and the MCP client support SIMD, then that is what you should use. That is going forward. That is the path for enabling authorization servers to work with arbitrary MCP clients. If they don't, which is the most likely case right now, Then you're going to use DCR, Dynamic Client Registration. And we're calling this the legacy fallback, but it's also like what is actually most common right now. So going forward, SIMD is, in the future, we're hoping that that it's all going to be SIMD. Right now, practically, we are mostly using DCR because SIMD is so new. So let's talk about SIMD first, because that is the wave of the future. So the way that SIMD works is that the MCP client itself is going to host a SIMD document that describes itself. It says, hey, I'm an OAuth client. Here's my information. Here's how you should work with me, right? Now, VS Code actually does support SIMD already, right? So we've talked about how great VS Code is at supporting MCP. They're one of the first clients that is supporting SIMD, and they've got their SIMD document. So you can actually look at the VS Code SIMD document, right? So the goal is going forward, like that we'd expect, I think Cursor just announced, Cursor does have a SIMD. I think I saw that earlier this week. Presumably Claude must have a SIMD, right? So hopefully more and more of these, desktop applications and other MCP clients will add these SIMDs. Now, they do have to be at a HTTPS URL. Luckily, most people have a domain that they can, make an HTTPS URL and put their SIMD here. But here you can see, so Visual Studio Code says, okay, I'm an this is my OAuth client information. Here's my grant types. Here's my redirect URIs. Here's the ID of this document itself. Right. So it gives all this information that tells describes how to work with it as an MCP client. So that's what the MCP client has to support, is having that SIMD document. And so now here's what the flow looks like with SIMD. So if the user, wants to use an MCP server and, it sees that the client, if the client has a client ID, it has a SIMD, it's going to specify its SIMD URL when it's making the authorization request, right? So normally client ID would be this numeric thing, like client ID equals 1, 2, 3, 4, 5, 6, right? In this case, it's going to say, hey, my client ID is this HTTPS URL, which is actually the SIMD document. And so then the authorization server, when it's validating the client, if it supports SIMD, it will detect that the client ID is a URL, and it will go and fetch that URL from that metadata endpoint and get back that JSON. And then the authorization server will validate it and make sure that from a security perspective, everything checks out, that everything matches, it all lines up, right? It says, okay, this is a valid SIMD, this looks good. And then the authorization server will say, okay, based on that SIMD, here is the client that you want to consent to. Do you consent to this client, right? And then we go through the rest of the OAuth flow. And it's just whenever the client is interacting with the authorization server, it's always going to be passing its client ID as that SIMD document instead of a numeric ID. Okay, so that was SIMD. That is the wave of the future, and we're all hoping to move towards SIMD. And ideally, I would only show you SIMD today, except that practically it's just not well enough supported yet on both the client side and the authorization server side. So we need another 6 months or a year to get to everyone really on board with SIMD. So we do need to talk about DCR. So with DCR, dynamic client registration, here we're actually going to dynamically register the clients. So the MCP client is going to ask the authorization server, hey, here's my information. Basically, imagine all that information that we had here. The client is going to send all that information to the authorization server and say, hey, can I register? Is that cool? Here's all my information. And the authorization server needs a database where it's going to store that client information and say, okay, I accept your registration request. I'm going to store it, and I'm going to issue you a client ID, right? And so now the MCP client has an ID, and then going forward, it'll use that numeric ID with all of its flows, right? And then the rest of the flow is the same. So the difference is just there's this registration step. And so that has to be implemented, supported on the authorization server side. And the authorization server has to add a database. And that's why many authorization servers didn't want to add support for DCR, because then they have to add, they have to have a database. And whenever you have to like start storing data, like you have the risk of, oh, how big does this database need to be? Like, when can I remove information from this database? There's also a risk of a kind of a DDoS attack, right, to this /register endpoint. So there were so many downsides for authorization servers that that they weren't implementing DCR. And that's why the MCP community came up with SIMD instead as something that would be more friendly to authorization servers, that would be easier for them to support. Okay, I know, I see my eyes. Yes, there's been a lot of diagrams. I think we're nearly through the diagrams now. But the thing is, you have to kind of understand all the different parts of the MCP auth flow, because the support for them is so variable. And so you kind of have to know what parts of MCP auth are not supported by your particular like setup and provider, so that you know what the workaround is that you need to use. So let's talk about support for full MCP auth. Who supports it? Which authorization providers? Because most of this comes down to the authorization provider. We also saw that for CIMD, it also depends on the client, but most of this has to be done by the authorization provider. And all of it requires at least some support by the authorization provider. Like even, for CIMD, it has to fetch that document, right? So unfortunately, Microsoft Entra, which is probably what many of you want to use, given this is the Microsoft Reactor channel, it only supports the metadata discovery, that well-known path that has the metadata. It does not support SIMD, does not support DCR. I would guess it probably would never support DCR now that that's the legacy thing. I'm hoping it's going to support SIMD, given that's the wave of the future. So let's all cross our fingers for SIMD support in the future. So unfortunately, Entra has a bunch of X's. We will still see a way to work around that, though, for those of you who want to use Entra. Now, today, we're also going to show an open source identity server. If you don't need to use an existing identities, you just want any identities, we're going to show how to use Keycloak. And that one does support DCR, though it has some bugs that we'll work around. And then there's got some other options here. So like Dscope and AuthKit, those are both identity servers that do optionally wrap Entra. So those could also be options for you if you want to use Entra, but you need this DCR and SIMD support, which is really nice. There's also Okta Auth0. That's another hosted identity server. There's ScaleKit, another hosted identity server. And we're going to have a demo of ScaleKit in office hours from Bernhard, who's in the chat. So definitely come to office hours after to see that. So you can see like the newer identity servers like this, that are, like startups, like they're very fast to implement SIMD. We're being a little slower on the Entra side. So if you want to use OAuth with a Python FastMCP server, how can you do that? Well, the FastMCP team has tried to make it very easy to add in OAuth providers. They have this base class OAuth provider that that is designed to make it easy to connect your FastMCP instance with whatever auth provider you want to use. And we can break that into two subclasses, right? So there's if the OAuth identity provider has full support for DCR, then you can use this remote auth provider class. So that is and then there's even like subclasses for specific ones like ScaleKit, Dscope, Supabase, AuthKit, etc. If there's no DCR support, then there's this OAuth proxy subclass, and that one will implement DCR on top of it. So the DCR will actually be implemented on your server itself and then proxy to the identity provider. So it uses the OAuth proxy for quite a few of the options, right? GitHub, Azure, which is Entra, Discord, etc., right? So that's generally the approach, is you're either going to use a remote auth provider or an OAuth proxy provider. So first, let's look at how we can use a remote OAuth provider that does have full DCR support, and hopefully in the future, SIMD support. So here I have an example of how easy it could be if you're using a host provider that is fully compliant, right? So if it's fully compliant, then FastMCP makes it very easy. So here we've got the scale kit provider, and we say, hey, this is the scale kit URL. Here's our resource ID. Here's my MCP server's base URL, and these are the scopes I want. And then you just pass them into the FastMCP class and say, hey, this is my auth provider, right? Look how easy that could be. And this is what Bernard will demo in the office hours if you want to see scale kit. So that's lovely. Like that's just 5-line setup, and boom, you've got full auth on your MCP server. That's the dream, and that works for many of the auth providers, but not all of them. So let's talk about Keycloak. We wanted to show Keycloak because it is an open source identity server that anyone can deploy with a Docker image. So if you wanted to bring your own, set of users and groups to an MCP server, you could use Keycloak to do that. And we wanted to work with Keycloak because we heard that it had full DCR support. Now, we found out along the way that it also had some open issues with DCR. And props to my colleague Gwen for working through these issues and figuring it out. She implemented the Keycloak in the repo. So yes, it supports DCR, but no, it doesn't support it perfectly, right? So we did have to do a little bit of a workaround. So the way we implement auth with Keycloak is that we create our own subclass of remote auth provider. And then that subclass, basically, you can check the code, but it basically has to override the register route in order to fix some headers that are wrong, right? But then once we did that, then we can set up a connection to the Keycloak provider with our Keycloak URL, our scopes, and our audience, and it works. So we have all the code written for that in our Python MCP demos repo, the one we've been using for most of our demos. So if you do want to try Keycloak, you can follow these deployment steps. So you're going to set the auth provider to Keycloak, and then you're also going to set your super secure password, which you should certainly change later, and that will give you, the ability to access the admin. And then once it deploys, it's going to set up a Keycloak container app that is actually the Keycloak image, right? So here I've got it. Okay, Keycloak, right? So this is actually, I'm logged into the admin. So you can see this is a Keycloak admin. I'm logged into admin with my super secure password. And you can see we've got realms. Realms are like tenants, if you know Entra stuff. We've got users, groups, clients, lots of things we can configure here for this identity server, right? So now I've got that Keycloak deployed, and I also have the MCP server deployed, the one that has the Keycloak provider, right? So here I've got my auth MCP server, and for Keycloak, we've got it set it up here where it's using the auth provider. Okay, so that's all set up. So I want to actually show you the whole flow. Let's see if I can show you the whole flow, because I think it's really interesting to see the whole flow of doing the OAuth flow. So let me try running this authmcp.py. Oh, wait, we're already in here. Okay, let's just run. No, let me look at my README. That's why I always document things, because I'll forget as soon as okay. Here we go. I'm going to run it using Ubicorn. Okay. All right. This is running. Okay. All right. So I'm going to run this server. Right now, it should be using Keycloak as its authentication. Let's check the logs. Okay. It says using Keycloak DCR. Here I'm running the server locally. I also have this server deployed, but I want to show it locally, so I'm going to show you the logs and see what's going on. And this is like the realm, which is like the tenant. Okay, so now it's running. So what I'm going to do is go to my mcp.json, and I'm going to tell it to start the local host server. So what I want to show you in the logs, it's kind of hard to see because it grays it out, but see, at first, right here, it tried to make a post /MCP and it got a 401 unauthorized, right? It said invalid token. Great. So now VS Code knows when it gets that 401 that, oh, it has to go do the look to see if there's an authorization flow, right? So first it goes to that PRM URL, and you see that it's a 200 for that PRM URL. That's that well-known OAuth protected resource. Then it also goes to the authorization server, and that one, it's on our server too, because we are proxying everything that MCP Auth needs. And that gets forwarded to the actual Entra URL. And then it's trying to do the post to the register. Okay, we're doing allow, open. Okay, so this is going to Keycloak, and then it wants me to log in. And I'm going to log in with my super secure test account. You should delete this when you're doing in prod. All right, and then we log in. So I'm logging in as test user, and I showed test user here, right? So now it says sign in successful. We go back to VS Code, and what you see is that it successfully created the client. And now when it's doing all these posts to the MCP server, it is getting 200 OK. So that means it is now accepting the token. So VS Code now knows how to send requests to the server with a token that is authenticated. And so now if I actually use this server, let's see, go here and I'll turn this one on. Okay. All right. I bought $67 of avocado toast on my Amex. Okay. All right. Let's see if it's going to use this server here so that we can see some more requests going out to it. All right, so it wants to use this server that's running here, the one we can see in the terminal. So I'm going to say allow, and we should see another request go out to this server here. Running. All right, going here, localhost. Okay, still running that. There we go. All right, so we see it went to the server. It's adding the expense. Now what I want to show you is going to the Cosmos DB for that server. I think it's okay. It's all done. Great. That one's all done. Now, if I go to the Cosmos DB for that server, what you can see is that here's the $67 of avocado toast. And notice now we have a user ID. And see this user ID, it starts with 0159. If I go to my Keycloak admin, I click on test user. Of course, it just kicked me out because I did a different login in here. And so it doesn't think I'm the admin anymore. So let me go ahead and get my, no, it's in here. Let me get my super secret password. Great. All right, here we go. So if I go, and so here I looked at the user, I clicked on this and see this ID here, 0159, 0159, 0159. So what we can see is that we've actually used the user ID from the token. And so that's in here, we added this token user auth middleware. And basically we get back the right claim. So we use this claim here, and that gets us back the user ID. And so then when we're actually storing the user ID in the container, that user ID is the actual identifier of that user in the Keycloak system. Okay, so there we go. So that's Keycloak, and I showed it in localhost just so I could show you the logs, but it also works on the deployed URL. So I actually have it. I've got the deployed server here, and that works as well. And that's what you'd actually be using, when you're doing this for production. All right, we have 5 minutes left, and of course we need to talk about Entra because that's what probably many of you are interested in. So Entra does not support DCR, does not support CIMD. So we do need to use the OAuth proxy approach. And so here, the FastMCP server is going to be adding the routes on top that it needs for doing registration. And even actually our Keycloak kind of was an OAuth proxy too, just because of that one bug. So close to full DCR, but so far. So basically, yeah, we're going to use a full OAuth proxy approach that's going to compensate for everything that Entra doesn't have. And because of that, we also need to add on a database for client ID storage. So we're going to use Cosmos DB since we're already using Cosmos DB, and it's a good place to store the client IDs. So that's what we're going to set up is this proxy, and FastMCP already has a built-in proxy for it. So that's the Azure provider class, and it's a subclass of their OAuth proxy class that implements the DCR for us. So that's in this Auth-MCP, right? So here, if we're doing Entra in production, I set up the Cosmos DB store. And, locally, I just use in memory for the clients, and then set up that Entra with our client ID and client secret with the tenant that we're doing the authentication with. We're doing a single tenant auth here with the base MCP URL, with the scope we want, and with our client store. So that's what sets it all up. And now let me just actually show you that flow. I'll just do it with this one, right? So I've already authenticated to this one, but what I can do is to show you it again. I'm going to remove the setup of this in VS Code to force it to go through the flow again. So I'm going to remove it here. Okay. All right. And then I'm going to close down the Keycloak server. I'm going to check this off. I'm going to check Entra on. And I'm going to start that Entra server. Okay, so start. All right, it says it wants to authenticate. And we're going to open this up. And notice this is a FastMCP screen instead of an Entra screen. And that is because we're using the FastMCP OAuth proxy, right? So we allow access here. And very quickly, you might have seen it did go to the Entra login endpoint in the tab there. So it did do the Entra flow in the tab. It just happened very quickly. So now that's running, and it says it has two tools. So let's go ahead and make sure it has access to that one, Entra. Okay, so I got three lobster on my Amex today. Okay. All right, let's see if it'll go out. And I did it already earlier today too, so I can show you this is the Entra one. So in the Entra one here, my user ID is in fact my Entra OID, my Entra object identifier. That is this user ID here. All right, so here it wants to add it to the Entra server. So it is calling that tool. It said it has logged it. We can refresh here and see the new one, 322 of lobster. And this is my Entra object ID. So even though we use the FastMCP proxy, it is getting access to my Entra account, right? So we are pulling out the OID from that access token and using that as the user ID in this Cosmos database. Okay. So if you want to, now we've implemented all of that once again in the repo. So if you want to try the Entra OAuth proxy, you can follow these steps to set it up. It will create everything for you. I did even automate the creation of the Entra app registrations. I did that in the auth init scripts using the Microsoft Graph SDK. So you can see when I set up the app registrations, we've got, this limits it to our tenant. I set up the redirect URIs. I set up the scope for the MCP server. So all of that is set up in the code. So if you want to set up something similar, just take our code and start with that as a basis so that you can then build on it for your own. So as you saw, we were able to use it and that worked. Now, it is possible that maybe you don't need this support by arbitrary MCP clients. In that case, you don't have to use the proxy. You could just use pre-registered client IDs, right? Specifically, if you're doing just for VS Code, there is a known client ID for that. And you could just pre-register your that client with your Entra app. So there's an example of doing that with Azure Functions. So that same repo I showed earlier, it actually has support for doing pre-authorized client IDs. So here's the VS Code client ID. So you could deploy an Azure function, and it will work with VS Code because it'll be a pre-registered client ID. So that could also be an option as well. I want to throw it out there in case that's helpful for you. Whew. All right. We made it to the end of our epic day about Auth, which had a billion diagrams. Hopefully they helped. And I do recommend, I mean, with OAuth, I do recommend just really digging into it. And it helps to to read through different documents that explain things in different ways, to actually watch the OAuth flow yourself and see the URLs that go by. OAuth can be so complicated, and it's always fun for me to get an excuse to learn it more, but there is always so much more to learn. So that is the end of today's session, and also the end of the series. But we do have office hours right after the series, and Bernard is going to be demoing ScaleKit in the office hours. That's in the Discord. So I hope a bunch of you can hop over to the Discord and join us for the office hours. And so we'll see that demo. We'll also answer other questions. I know I didn't have any time today to answer questions at all because we had so much to cover. I really think this session needs to be like 2 or 3 sessions in the future. So that's also come to the office hours in order to see the demo and also ask more questions. And as a reminder, you can rewatch all these videos, get the slides, get the code. You can keep learning. We've got our MCP for Beginners series that you can go through as well. And there's so much to learn in MCP. I think it's really exciting technology. I see a lot of momentum around it, and I think we're going to all keep building on it and making it great together. So thank you all so much for joining. We are going to hop into the Discord now and hope to see you there. Bye, everyone.
Thank you all for joining, and thanks again to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.